Saucier, this is a video lesson on multiple solutions. We're used to getting multiple solutions out of equations when the equations are quadratic. We also get multiple solutions very often when we solve systems. In this case, I'm going to show an example of the system of two equations, x squared plus y squared is equal to 25, and y is equal to x squared minus 13. Before we get into the process of calculating those solutions, it's generally a good idea in a complex situation to get an idea of where the solutions, the approximate solutions ought to be, and more importantly, how many you might have or expect to find. In this case, we're going to do that by graphing these two equations. We find solutions when the graph of functions intersect. The graph of x squared plus y squared is a circle. It's not a function. This will graph as a circle with a radius of 5. The second equation is quadratic, so we should expect it to be a parabola. Graphing the circle, we have a circle whose center is at the origin with a radius of 5. The first equation's graph looks like this, approximately. The second equation is a parent quadratic that has been moved down 13. So the vertex is at 0, negative 13. I've been counting by 2's, so I'll find 13 about here, or negative 13. Graphing the parabola. Looks approximately like this. Graphing these two equations will give solutions at its point of intersection. And it looks like the parabola intersects the circle at 4 locations. So we should have 4 solutions. And when I go through the process, the solutions ought to be approximately around what looks to be 5's and 3's and 4. So with that as a guide, I'm going to use the process. Which one? How? What immediately comes to mind, since this is solved for y, is to replace what y is equal to into the first equation. When I do, I get x squared plus what y is equal to, x squared minus 13 all squared is equal to 25. I substituted in the second equation into the first. What I got is, after I distribute the x squared minus 13, is x squared plus x squared minus 13 all squared gives x to the 4th minus 26x squared plus 169 is equal to 25. And I can see that the result of my first choice gave me an equation with an x to the 4th in it. And I'm not so confident that if I combine like terms, I'm going to end up with something that'll be easy to solve for x. It's not quadratic. Maybe there's a different first choice I could make. If I look at this second equation, instead of solving it for y and substituting in what y is equal to, the x squared is the problematic piece. So if I take the second equation and I solve it for the x squared term by adding 13 to both sides, I get the equivalent equation, x squared is equal to y plus 13. Again, I took the second equation and solved it for x squared by adding 13 to both sides. Now I can do a different kind of substitution. Instead of replacing y in the first equation, I can replace x squared. When I do, I'm going to rewrite the first equation, but instead of x squared, I write what it's equal to, y plus 13, and then continue on, plus y squared is equal to 25. I have a quadratic equation. Sure, it's in terms of y, but that's fine. I can use the quadratic formula to find the values of y. Let's proceed by subtracting 25 from both sides and putting it in standard form. Standard form, the squared term will come first, then y. If I subtract 25 from both sides and combine it with a positive 13, then I get minus 12 is equal to 0. My coefficients for this quadratic is a is equal to 1, b is equal to 1, and c is equal to negative 12. Let's use the quadratic formula to solve for y. Y will be equal to negative b plus and minus the square root of b squared minus 4 times a times c, which I'm going to represent as a 12, and then the negative of negative 12 will change the sign out in front, all over 2a. So y is equal to, cleaning up the radical, under the radical I have 4 times 1 is 4 times 12 is 48. 48 plus 1 is 49, and the square root of 49 is 7. So I have y is equal to negative 1 plus and minus 7 all over 2 is equal to, I should expect two solutions. Negative 1 minus 7 is negative 8. Negative 8 divided by 2 is negative 4. And negative 1 plus 7 is positive 6. 6 divided by 2 is 3. I have two solutions for y, which is only half of the point information I'm trying to find. So I need to use my values for y to find x. How am I going to do that? I have a couple of choices. I have the equation x squared plus y squared is equal to 25. I could substitute my values of y in for y and rewrite this equation. So I'm going to rewrite the first equation, x squared. But when I get to the y squared, I'm going to replace it with one of my values of y, in this case 3. So 3 squared is 9, and that will be equal to 25. But that's not the only value of y that I could be using. I could be using negative 4. So I have a second version of this equation. X squared plus, in this case, negative 4 squared is going to be plus 16 is equal to 25. Using my two values of y and substituting it into the original equation created two forms of that equation. And I need to find all of the solutions for x in both of these equations. I'm going to take these, both equations, and I'm going to subtract 9 in the first one. When I do, I get x squared is equal to 25 minus 9 is 16. And in the second equation, I'm going to subtract 16 to get x squared by itself. And when I do, 25 minus 16 is 9. Keep going with these equations. I need to take the square root of both sides in both equations to get x by itself. And when I do, I get x is equal to the square root of 16 is 4. But remember, when you clear a square, you have to remember to add back the possibility that you got both the plus and minus version of the other side. So x is going to be equal to both plus and minus 4 in this first equation. In the second equation, I'm going to take the square root of both sides to get x by itself. And on the other side, the square root of 9 is 3. But again, it's going to be both the plus and minus versions of those signs. I just found all of the values of x. So in a result, I've got 2 values of y and 4 values of x. How does that match my expectations? Well, there are 4 points here. How can I find the coordinates of these points? I've got 2 values of y. So the values of the points above the x-axis have a y value of 3. One of the solutions to y. And the bottom points have a y value, which is the second solution of negative 4. The x values, there are 4 of them, are the x values of these 4 points. The way it must be arranged is I've got 2 positive x values. This is the 3 and the 4, and 2 negative x values, or in this case, a negative 3 and a negative 4. So the process, though it was rigorous, confirmed what I expected, 4 points, 4 coordinates. 4 distinct values for x and 2 for y.